Hello friends, welcome to Spectrum Academy. First of all, I would like to thank all of you for staying connected with this channel, and I'm very happy to announce that we have reached 500 subscribers last week, and it is all possible because of your love and affection, and it really makes me feel special that you derive some benefit from my channel by watching these lectures. Now, very important thing I would like to share with you is last couple of days back I got messages from some of the students from NIT Srinagar, Jammu Kashmir, and they shared their difficulties with me. And the problem was that due to continuous curfew situations in Valley last 5-6 months, the regular lectures could not be conducted, and they have examination in first week of Jan. So one of my video lectures on higher order differential equation they found very useful. Now they requested me to put a part 2 on that particular video. Although of late I was very much professionally occupied, I thought it is my moral responsibility to come out with a video on differential equation part 2 and help those students who probably have certain faith on me. So here I'm going to put this part 2 video on higher order differential equation, and out there my students, in those who are watching from Kashmir, I know you have exam from 2nd of Jan, and I'm sure this is going to be helpful for you. So without wasting much time, let's begin. So let's start. Higher order linear differential equation which is homogeneous is of this form. If you want to solve this, first step is to form the auxiliary equation. The question is, how do we form the auxiliary equation? It's very simple. This ft, which is polynomial in D, will be equated to 0, and the equation which we get is called as auxiliary equation. Once we form the auxiliary equation, the next step is to get the roots of auxiliary equation. And as we discussed in part 1 video, based on the nature of roots, we can find out the solution of the given differential equation. So now let us discuss how to identify the nature of root, and based on that, how to write down the solution of given differential equation. So suppose the roots are some real numbers and distinct real numbers. For example, m1, m2 and m3 are distinct real roots. Then the solution, which is also called as complementary function, please note the solution is called as complementary function, and it is given by y equal to some constant c1 into e raised to m1x plus some other constant c2 e raised to m2x plus some constant c3 e raised to m3x, and it carries on. If there are more roots, you can write similar terms here onwards. Now if the roots are real and equal, for example m1 are the two roots but they are equal, so in that case we write down c1 plus c2 into x e raised to m1x. Now suppose this m1 is repeated 3 times instead of 2. Here it is repeated 2 times, but suppose it is repeated 3 times. And how would we write? We can write it like y equal to c1 plus c2x plus c3 x square into e raised to m1x. So if m1 is repeated 2 times, this is how you write, and if the roots are repeated, say same root m1 is repeated say 3 times, this is how you write the complementary function. Next we talk about imaginary and distinct. Then how we write the solution? The solution is e raised to alpha x into c1 some constant cos of beta x plus some other constant c2 into sine of beta x. Now suppose the roots are imaginary and repeated. Alpha plus or minus I beta is repeated 2 times. So in that case it is e raised to alpha x in the bracket. We write c1 plus c2 into x cos beta x plus some constant c3 plus c4 into x sin beta x. So to remember these combinations very thoroughly, these are going to help you to find out the solution of differential equations by looking at the nature of roots. So see, they ask us to solve this particular question, this differential equation, which is fourth order differential equation. So first thing what we do is we replace d by dx as d. So what we get here is d raised to 4, this is 6 d cube plus 15 d square plus 20 d plus 12 of y is equal to 0. So first thing is we form the auxiliary equation. Remember how we form auxiliary equation? This polynomial in d is equated to 0. Now we have to solve this polynomial in d. We can use synthetic division. What is coefficient here? 1, then here 6, then here 15, then here is 20, then here is 12. I can go for minus 2, then it becomes say 1, then this becomes minus 2, this becomes 4, this becomes minus 8, and then this becomes 7, this becomes minus 14, this is 6, and this is minus 12, and this is 0. So what are the factors of this? The factors of this would be d plus 2 into 1, 2, 3, 4. So it is d cube plus 4d square plus 7d plus 6 is equal to 0. Now this is again a cubic polynomial. To simplify this cubic polynomial, once again we have to use synthetic division. So once again we have to use synthetic division. So what I can do is I can write here now the coefficients here are 1, 4, 7 and 6. 1, 4, 7 and 6. So I can divide this by say minus 2, and becomes 1, this becomes minus 2, this becomes 2, this becomes minus 4, this becomes 3, this becomes minus 6, and this is 0. So factors for this cubic polynomial would be, it is getting divided by minus 2, so the first factor would be d plus 2, and the second factor would be it is d square plus 2d plus 3, and that is equal to 0. Now let us simplify this. D square plus 2d plus 3 equal to 0. If you simplify that, you will get d equal to minus 2, this will be d equals to minus 2, and this will be d square plus 2d plus 3 is equal to 0. So now roots of this would be d is equal to, it is minus 2 plus or minus root of, it is 2 square, that is 4, minus 4, 1 into 3 divide by 2 into 1. So here the roots are going to be finally it is minus 1 and plus or minus root 2i. So these are the roots we are going to get. So look at the roots. It is d equal to minus 2 minus 2. It is real and repeated. And look at this, it is complex or imaginary. Now based on the nature of roots, we can write down the solution. So what is yc? Yc is the complementary function, which is the solution. Now the first pair of roots are real and repeated. So remember, how do we write the roots? It will be c1 e raised to since it is repeated, be very careful, it is c1 plus c2 into x e raised to minus 2x plus, look at these roots, it is like alpha plus or minus beta x. What is alpha? Minus 1. And what is beta? Root 2. So to e raised to alpha x, that means minus 1 into x into C1 C2 are already used, so let us use C3 cos beta. Beta is root 2x plus C4 sine beta x. Beta x is root 2x. So this becomes your solution of the given differential equation. Hope you understand, and this is helpful for your examination. I hope you understand the method discussed in this video. Due to time constraint, I am not able to put more problems for practice, but once you follow this procedure which I discussed here and practice this procedure using several problems, I'm sure this is going to be a lot easier for you. And all my Kashmiri friends out there who have examination on 2nd January, especially NIT Srinagar, the students from NIT Srinagar who requested for this video, wish you all the best for your examination. And yes, do like this video and subscribe to this channel and share with your friends who might be requiring this, just before examination as you require it. And this is year end, so I take this opportunity to wish you all a very happy and prosperous new year. Thank you very much for staying connected, and I hope you stay connected. Wish you all the best. Thank you very much. See you later. God bless you all.